Welcome pre-cal students to the homework help video. Here's the assignment right here, and hopefully any questions that you have on any of these problems will get answered during this video. Okay, well, let's go ahead and get started. I believe the directions are pretty much the same all the way through. We're just solving different types of equations, so let's go ahead and get started. Here's number 3. We're going to solve this equation. Now, the steps that I gave you for a rational equation is number 1, let's get rid of this 3 here. Number 1, factor any denominators that can be factored. None of these can be factored. Number 2, eliminate fractions. So I have a denominator of 4 and a denominator of 5. A common denominator for 4 and 5 would be 20. So I'm going to multiply this entire equation by 20 over 1. So here we go. 20 over 1 times this fraction. Your 4 would cancel into your 20. 5 times, so you're going to take 5 times x plus 2. If you do that correctly, you will get 5x plus 10. Now please be careful with this minus sign right here. My advice to you is to go ahead and bring it down right now like this, and then put a parentheses. And now you can totally ignore this negative sign and don't worry about it, okay? You brought it down, it's here, and you're going to worry about it later, not now, okay? Okay, let's take 20 over 1 times this fraction. Your 5 would go into 20 4 times. And now take your 4 and multiply it times x minus 1. If you do that correctly, 4 times x would be 4x. And 4 times negative 1 would be negative 4. See how I did that? I did not even have to worry about this negative sign. I just took 4 times x and 4 times negative 1. Okay? All right, and then of course 20 times 15 would be 300. And now, in your steps, I told you to solve the equation that's left over. So here we go. We should know by now when you have a negative sign outside of a parentheses, you multiply it through. So a negative times a positive is a negative 4x, and a negative times a negative is a positive 4. And now I'm going to finish this very quickly. We know that 5x minus 4x would be x. And we know 10 plus 4 is 14. And then bring that 14 over and make it a negative 14, and you should get 286. Now I'm looking at the answer key here. Yes, that is correct, 286. Okay, moving on to number 7. All right, same thing. Rational equation. Step 1, factor the denominators if you can. You cannot factor this, and you cannot factor this. So go on to step 2. Step 2 says to find a common denominator and multiply it. Well, it says to eliminate the fractions. So we're going to eliminate these fractions. Now, we compare binomials with binomials, monomials with monomials. Here is a one-termer right here, and here is a two-termer. How many groups of 2x do you have here? 1. How many groups over here? None. So the most that you have is 2x. And then how many groups of 3x plus 2? 1. And how many groups over here? None. So then I'm also going to use one group of 3x plus 2. So there's my quote-unquote common denominator that I'm going to multiply through this fraction. Okay? So I'm going to grab it, pull it over here, and let's multiply the entire equation by this fraction. There we go. Okay, let's take this fraction here times this fraction here. If you do that correctly, 3x plus 2 is going to cancel with 3x plus 2, and you're left with 2x times 5. 2x times 5 would be 10x. Bring down your equal sign. Now we're going to multiply this fraction times this fraction. If you do that correctly, your 2x will cancel with your 2x, and you're left with 3x plus 2 times 3. Well, 3x times 3 would be 9x, and also 3 times positive 2 is a positive 6. And now step 3 says to finish the equation. So you know what I forgot to do over here in the last problem? You should always check for extraneous solutions, and if you put this into your equation, it will check, okay? Okay, step 3 says to finish the leftover or the remaining equation. Bring your 9x over and make it a negative 9x, and you're left with x equals 6. X equals 6. Well, if you substitute that in and check your answer, you will see that it does work. And you always need to do that on these rational equations, okay? Because sometimes you will get extra or extraneous solutions. All right, number 11. Now we're getting a more difficult problem, which I enjoy the more difficult ones. So here we go. Number 1, step 1, factor your denominators. Well, this denominator cannot be factored. This denominator cannot be factored, but this one can. So we're going to factor that one denominator. We no longer are going to have y squared minus 9. You should remember how to factor this. We know the square root of y squared. We know the square root of 9. Your first term is positive. Your second term is negative. So here we go. The square root of y squared is y, so we put that here and here. The square root of 9 is 3. We put that here, and we make one positive, and we make one negative. Our next step, step 2, is to eliminate fractions. Well, we're going to have to find a common denominator. Here's a binomial, y plus 3. I have one of those. I have one y plus 3, none here, and I have one right here. So which group has the most? Well, these two groups both have 1, so I just need one group of y plus 3. Now, let's look at another binomial that I have right here. And that's my, I think I messed up here, y plus 3. There we go. That's my y minus 3 binomial. I have one group here, right here, of y minus 3s, one group. I have none here and none here, so which group has the most? This one does, and it has 1. And then lastly, I'm looking at a monomial. I have a one-termer right here, a y. And don't look at this y here. That goes with the y plus 3. That's a two-termer, a binomial. So there's a binomial here, a binomial here, a binomial here. I only see one monomial. And here it is. So I have one group of a y here. I have none over here. I have none over here. So the most that I have then is just 1. So I'm going to put one y right here. So there's your common denominator. I'm going to grab this whole thing, and we're going to multiply the entire equation by this fraction, okay, to eliminate fractions. So here we go. Put parentheses here, and here we go. Let's have some fun. When you multiply this fraction here times this fraction here, your y plus 3 should cancel with your y plus 3. So you're left with 6y parentheses y minus 3. There we go. And if you think, well, that's confusing, if you want to put this, I'm not going to, but if you want to put, 6 parentheses y, all of that, that's totally fine, but it's good enough just to put 6y, y minus 3. Okay? Now, actually, I should have first got rid of my slashes up there. Okay, so I'm left with 6y, y minus 3. Okay, now let's multiply this fraction times this fraction right here. Okay, well, notice your y will cancel with your y, so you're going to take y plus 3 times y minus 3 times 2. Okay, so basically what you'd have, bring down your positive sign, you would have a 2, and then y plus 3, and then a y minus 3. Now this will be a lot of work, but it's not going to hurt you guys. And then bring down your equal sign. Now we're going to take this fraction here times this fraction here. Okay? Well, if you do that correctly, your y plus 3 and your y minus 3 are going to cancel with your y plus 3 and your y minus 3. And you're left with a y times this numerator right here. Okay? So we're going to take y times 5y. Hold on one second here. And then we're also going to take y times negative 3. So y times 5y is 5y squared, and y times negative 3 is negative 3y. Now, the next step says to solve the remaining equation. Well, if I gave you this equation, you should know how to solve it. First of all, you know to simplify all of your sides. So very quickly, 6y times y is 6y squared. 6y times negative 3 is negative 18y. Now, I'm going to go ahead and simplify this down here. Notice how you have a 2 right here. So I'm going to put a 2 and then a big parentheses. I'm going to do a bunch of work down here. And then I have y plus 3 times y minus 3. Well, if you multiply that correctly, you will get y squared minus 9, because just trust me, if you take y times y times negative 3, 3 times y, 3 times negative 3, and do all your simplifying, you will get y squared minus 9. And then there's a 2 here, so when you multiply your 2 through, you're going to end up with 2y squared minus 18. So all of this right here simplified down to this right here. Okay? All right, moving on. Now, as soon as I notice that I have a y squared equation, you really should know by now, students, to get one side equal to 0, because you're probably going to have to use the quadratic formula or factor. Okay, so we should know that by now. So I'm going to underline my terms. I have a 6y squared and a 2y squared. That's 8y squared. But I'm bringing this 5y squared over and making it negative, and that's going to leave me with a a positive 3y squared. I'm going to cross this off, cross this off, cross this off. Now my y terms, well, if you'll bring your 3y over, it'll become a positive 3y. And then you have a negative 18 and a negative 18. They're both on the left side of the equal sign. If you combine those, you'll get a negative 36. Now, for me, I always think factoring is the fastest way to solve these. That's just me, and I think it's always the best way to go if you're able to. Okay, so that's what I'm going to try to do. I'm not sure if we can factor this or not, but here are the steps that you should have learned a long time ago. Step 1, always pull out what's common. Well, 3 goes into all these terms, so I'm going to pull out a 3. And you're left with y squared plus y minus 12. Now that makes your factoring your trinomial a lot easier, because now you have a lead coefficient of 1. So all that you're going to say to yourself is, self, what two numbers multiplied together give me a negative 12, but when added together give me a positive 1. Okay, so here we go. Let's put a positive 4 and a negative 3. When you multiply those together, you get a negative 12. When you combine those, you get a positive 1. So bring down your 3, go ahead and put 2 sets of parentheses, and now you're left over with y plus 4, y minus 3. There we go. And now you should know by now, if a group does not have a variable, we're not worried about it, and this 3 does not have a variable, so I don't care about it. But I must take my other groups and set them equal to 0. And if I take this group and set it equal to 0, I will get a negative 4. If I take this group and set it equal to 0 and solve, I will get 3. So there's my 2 answers. Now step 4 is check for extraneous solutions. And if you put 3 into this equation up here, let me see here real quick. If you put a 3 into this equation, you're going to get out a solution that does not exist, because think about it right here. See this y squared minus 9? If I put a 3 right here, I have 3 squared, and 3 squared is 9, and 9 minus 9 is 0. So as soon as you have one denominator with a 0, you know that you cannot solve this equation using the number 3. It does not work. So 3 is an extraneous solution. Okay? All right, let's continue on to number 15. Number 15, make this a little smaller so we have a little more room to work with. And here we go. Now, step 1 says to factor your denominators if possible. This cannot be factored, this cannot be factored, but this one can be factored. So here we go. I'm going to put 2 parentheses right here. I notice that I know the square root of x squared. I know the square root of 25. The first term is positive, the second term is negative, so I put an x here, and an x here, and a 5 here, and a 5 here. Make one positive, make one negative. So I'm going to scribble all this off here. Okay, there we go. That's called factoring, and we've done that very well. Step 2 says to eliminate your fraction. Now, eliminate your fractions. Now, let's get us a common denominator. I'm going to go ahead and do it over here this time. I'll put a 1 right here. Now, I have one group of x plus 5, I have no groups of x plus 5, and I have one group of x plus 5. Which group has the most? Well, these two both have 1, so I just need one group of x plus 5. Now I've got another binomial to look at, that's x minus 5. Well, there's no groups of x minus 5 here, there's one group here, there's one group here. Which group has the most? These both have 1, so I'd need just one x minus 5. Okay, now let's go ahead and eliminate our fractions. We're going to take this fraction times this fraction. x plus 5 will cancel with my x plus 5, leaving me with x minus 5 times 2. So x minus 5 times 2 would be 2x minus 10. Okay? Now let's go on and multiply this fraction here times this fraction here. Notice my x minus 5 would cancel with my x minus 5, leaving me with x plus 5 times 1. Right? So obviously x plus 5 times 1 would just be x plus 5. And then when you multiply this fraction here times this fraction here, all of this will cancel with all of this, just leaving you with 1. And 1 times 16, of course, is just 16. And now we're left with a very simple equation to solve. Step 3 says solve the remaining equation. So 2x plus x is 3x. And I'm going to skip some steps. You guys are big students. 2x plus x is 3x. And then if you combine a negative 10 and a positive 5, you'll get a negative 5. But then bring the negative 5 over here. And when you bring it over, it becomes a positive 5. And so you're left with 21. Now we're going to divide both sides by 3. X equals 7. Don't forget, when you're solving rational equations, you always want to check for extraneous solutions. If you substitute 7 into this equation, it will work. I'm going to go ahead and do one for you. I never do that, so I'm going to go ahead and put a 7 in and show you this works. Okay, 7 plus 5 is 12, so I have 2 over 12, plus 7 minus 5 is 2, so 1 over 2 equals 16. 7 squared is 49, minus 25 would be 24. Okay, so if I add these two fractions together, I should get 24. Let's see if, or 16 over 24. Well, let's make this fraction here 4 over 24. Let's make this fraction here 12 over 24. So I found a common denominator of 24. Well, Mr. Earhart, a common denominator for 2 and 12 is 12. I know, but I wanted the right side, I wanted the left side to match the right side, so I'm just going to use 24 for my denominator. And if you add these two fractions together, you'll get 16 over 24, which is exactly what you're supposed to have, because that's what you have right here. Now, if you want to use a calculator, just type these two into your calculator, and you'll get out 16 over 24. All right, moving on to number 19. Step 1, once again, we're solving a rational expression. Step 1 is factor the denominators that can be factored. Well, first of all, I can definitely factor this. I can pull out a 5. And if I pull out a 5 correctly, I'm left with this. Look at your next denominator. You can definitely factor this denominator. X plus 4. I'm going a little faster now on the factoring, but really this kind of factoring is Algebra 1, really, to be honest with you. So we should be able to factor this perfect square binomial pretty quickly. And now let's go ahead and find our common denominator, okay? First of all, I've got a monomial of 5, no monomials here, and no monomials over here. So which group has the most 5s? This one, and it has 1. So there's part of my common denominator. Now here's an x plus 4. One group here, one group here, no groups here. Which one has the most? These two, and they both have 1. Now let's look at my group of x minus 4s. None here. One group here, one group here. Which group has the most? Well, they both have 1. And so I'm going to use 1 x minus 4. I'm going to put all of that over 1, and that's going to be my common denominator that I'm going to use to multiply by this fraction, okay? Or by this equation, excuse me, I'm sorry. So I'm going to take this fraction here times this entire equation. And here we go. If I multiply this fraction times this fraction, 5 will cancel with 5. X plus 4 will cancel with x plus 4, and you're left with x minus 4 times 1. X minus 4 times 1. Well, x minus 4 times 1 would just be x minus 4. Now be careful when there's a negative sign here. That's so tricky. My advice to you is to just bring it down and get rid of it. So bring down your negative sign and then put parentheses, because this negative sign goes to everything you're going to get out of this fraction. So the best thing to do is whenever you have a negative sign between two fractions or between two expressions, bring the negative sign down. Now you don't have to worry about it. It's totally gone. okay? And then you put a parentheses here because the negative sign goes to everything from this fraction. Now we're going to take this fraction times this fraction. If you do that correctly, these two groups here will cancel with these two groups here, and you're left with 5 times 1. So the only thing that goes in this parentheses is 5, okay? And I should have first got rid of my slashes up here. There is a 5. So I guess I didn't need to make my parentheses that big, but nonetheless, that's how you would do that. All right. Now let's take our fraction here times our last fraction over here. If you do that correctly, your x minus 4 will cancel with your x minus 4, and you're left with 5x plus 4 times 3. Now my advice to you is to take 5 times 3. First of all, put your equal sign. I would put 5 times 3, or take 5 times 3, that's 15, and then put your parentheses x plus 4. That would probably be the easiest way to do that, okay? Now, step 3, after you've eliminated your fractions, step 3 says to go ahead and solve the remaining equation. And we really should know how to do this. This is pretty much simple math here, okay, to be honest with you. Now, here's what we're going to do. We're first of all going to simplify this side. I have x minus 4 minus 5, or negative 4 negative 5 is negative 9. If you're confused on this, use your calculator to help you. And then over here, 15 times x and 15 times 4. So 15 times x would be 15x, and 15 times 4 would be 60. And now we're going to go ahead and solve. I'm going to bring my 15x over here. When I do, it becomes a negative 15x. I'm going to bring my negative 9 to the other side. When I do, it becomes a positive 9. And now I'm left with negative 14x, because there's a 1 here, don't forget. And then 60 plus 9 is 69. Now divide both sides by negative 14, and 69 divided by negative 14 is negative 69 over 14. And you cannot reduce that. You cannot reduce that. Now, I'm going to admit to you, this is a real difficult one to check. But again, students, listen, with graphing calculators or with scientific calculators, it's not that hard. I mean, they do all the work for you. You would just take 5 times this fraction right here plus 20 under 1, then put your fraction over here, then do it here, then do it here, and then simplify everything, and you will get out a true solution. Okay, this is an answer to number 19. All right, number 23. Okay, here we go. Now they're getting into some really tough problems. Step 1 says to factor any denominators that can be factored. Now this is a quadratic trinomial with a lead coefficient of 1, so we should know by now that we can attempt to factor these. But this is interesting. You can't factor this. When you say to yourself, what two numbers multiplied together give you 4, when add together give you negative 2, it can't be done. So this trinomial, believe it or not, cannot be factored. Well, you can't factor this here, but oh, we haven't done these for so long. My goodness, this will be interesting, okay? All right, first of all, we do know the cubed root of x cubed, and we do know the cubed root of 8. So we can factor this. Sorry about that. Did not mean to do that. And so here's, if you don't remember, I'm going to refresh your memory. You put a little parentheses and then a big parentheses. All right. The cubed root of x cubed is x, and the cubed root of 8 is 2. And then whatever the sign is right here, you bring it down and you put that right here. Now, whatever this term here is, in your mind, you multiply it times itself. So x times x is x squared, and you put that right here. Then whatever this term is right here, you multiply it by itself. So 2 times 2 is 4. You put that term way over here. And then whatever this term is and whatever this term is, you multiply them together. Well, x times 2 would be 2x. And then whenever you have a positive sign here, over here we put a negative sign, and here we put a positive sign. Okay, that's just memorization, students. Okay, I hate to tell you that, but it really is just memorization. All right, so I can factor this, and now we're ready. We factored. So here we go. Looks like we have a trinomial here, a binomial here, a binomial here, and a trinomial here. Let's start with our trinomials first. I have one group of this trinomial, I have no groups here, and I have one group over here of the same trinomial. Well, which group has the most? Well, these two, they both have 1. So far I know that I'm going to need this for my common denominator, one group of this. Now let's compare our binomials, okay? I have one group of x plus 2, no groups here, one group here, so the most that I need is one group. There we go. There's my common denominator. I'm going to put it over 1, and I'm going to bring it up here. And I might have to shrink it a little bit. Yeah, I'm going to have to shrink it. So let's... And let's cross off this 23. Now I'm going to take this fraction times this entire equation. Here we go. Let's take this fraction here times this fraction here. We're now eliminating our fractions. This trinomial will cancel with this trinomial, and you're left with x plus 2 times 8. X plus 2 times 8. So if you do that correctly, you will get 8x plus 16. Now let's take this group here times this group here. And if you do that correctly, you will get x plus 2 will cancel with x plus 2. So you're left with this trinomial right here times x. Okay? So let's see what we get. We would have, let's see, it's an equal sign. X times x squared would be x cubed. X times 2x would be negative 2x squared, and x times 4 would be positive 4x. And now we take this fraction here times this fraction here. And if we do that correctly, we know that these whole groups will cancel with these whole groups here. So you're left with just 1. So 1 times 24 is 24. Now, as soon as I see, let me get a drink here. As soon as I see that I have an x cubed and an x squared, I know I want to get one side equal to 0 because I'm going to try to factor. So I only see one x cubed term. I'm going to bring that straight down. I have an x squared term here, no x squared terms over here, so I'm going to bring this straight down. I have a 4x here. If I bring my 8x over, it becomes a negative 8x. And if I combine those two, I will get a negative 4x. Alright, and then this positive 16, bring it over and it becomes a negative 16. And if I combine these two, I will get a positive 8. Now, the only way I've ever learned to solve an equation like this, there's other ways, but the only way that we've studied is to factor. And I'm not sure if you remember all the factoring we've learned. Hopefully you have. We try to factor a 4-term polynomial by grouping. That's our goal. So let's try to group and see what happens. When we factor by grouping, we pull out what's common in the first two, and we pull out what's common in the second two. So what's common in the first two terms is an x squared. So if you pull out an x squared, you're left with x minus 2. Let's check our work and see. X squared times x cubed, x squared times negative 2, negative 2x squared. Now, let's pull out what's common down here, or these last two terms. Whatever sign is here, positive or negative, you always put that right here, okay? Now, I'm going to pull a 4 out of both of these, and I'm not sure what I'm going to get. I'm going to go ahead and put x minus 2, because it really should match this, and let's see if that works. X minus 2. Negative 4 times x, negative 4x, negative 4 times negative 2, positive 8. So we're doing really well, thankfully. If it had not been factorable, it would have been a lot of work. Okay, you write your matching parentheses once, and then you bring down your x squared minus 4. Okay? Now, I know this is going to be a lot of work here, but if you'll look at this parentheses right here, we can factor that parentheses one more time, okay? So let's quickly do that. I'm just going to save some space and be a little, I guess, a little sloppy. If you factored x squared minus 4, we know the square root of both of those terms. X here, 2 here, 2 here. Make one positive, make one negative. All right? And now we're ready to solve. These rational equations are the worst one out of the entire assignment. We only have one more left. Okay, so we're doing pretty well on this. So here we go. Okay, if you take each group and set each group equal to 0, you're going to get a positive 2 for this group, a negative 2 for this group, and then a positive 2 for this group. So here's your two answers. Now, let's check for extraneous solutions. It's very important to do. And you're going to see negative 2 does not work. If you put a negative 2 right here for this x, you're going to get a 0 for your denominator. If you check the entire equation with a positive 2, you will see positive 2 does work. Okay, I'm not going to take time and do that, but trust me, I've got the answer key right here in front of me. It does work, okay? So there we go, number 23. Moving on now to number 27. All right, number 27, step 1 is to factor the denominators you can factor. You cannot factor this one, you cannot factor this one, but you can factor that denominator. You can pull an x out of both terms. So you're left with x minus 6. So pretty standard factoring. And now let's find our common denominator, okay? Here we go. Let's see. I've got a binomial here, a monomial here, a monomial here, and a binomial here. Well, let's see. Here's one group of x minus 6, no group of x minus 6, one group of x minus 6. So the most that I have in one group is 1. I have a group of x here, none over here, 1 here. The most I have is 1. So there's my common denominator, just like that. That's pretty simple. So I'm going to take that common denominator and I'm going to multiply it times the entire equation to eliminate my fractions. So here we go. If I multiply this fraction times this fraction, notice my x minus 6 will cancel with my x minus 6, and you're left with x times 1. X times 1 is just x. Now I'm going to multiply this fraction times this fraction, but hold it. See that negative sign right there? I've taught you what to do. Bring that negative sign down and put a parentheses. And everything you get out, be sure and put in this parentheses. Very, very important, okay? All right, so here we go. We're going to multiply the fraction times the fraction like I said. And so let's see what happens. X will cancel with x, leaving you with x minus 6 times 1. X minus 6 times 1. Well, that's going to be x minus 6. Next, bring down your equal sign, and then when I multiply this fraction times this fraction, notice all of this cancels with all of this. You're left with a 1. 1 times 6 is 6. And now we're just going to simplify. So here we go. Take your negative sign and multiply it through. Negative x, negative times a positive is negative, negative times a negative is a positive 6. Equals 6. Now we're going to combine, this is interesting, we're going to combine our two x's and we get 0x, they all cancel out. Bring your 6 over, you get a negative 6, you get 0. So basically everything canceled out on both sides and you're left with 0 equals 0. Do you remember from Algebra 2 what that means? When everything cancels out on both sides, that means the answer to the solution is all real numbers. That means any number will satisfy this equation. Isn't that cool? You're telling me, Mr. Harrod, I can put any number in and this equation will be satisfied? Yes, I am. That's true. Yeah, that's exactly what I'm saying. You can put any number into this equation that you want and it will work. If you don't believe me, try some. The only exception, though, don't forget, we do have rational expressions here. And so notice, what number could you never put into this denominator here? A 6, right? Because 6 minus 6 is 0. So we know the answer is all real numbers such that x does not equal 6. Now, what number could you put here that would make this denominator 0? Well, 0. If you put a 0 in for x, you'd have a 0. So we know that x cannot equal 0. And now, if you take your time and figure this out, you're going to see it's 0 and 6 for this also. And so the answer to this would be all real numbers as long as x does not equal 6 and as long as x does not equal 0. Now, if you don't believe that, throw some numbers in. Throw in a 1. If you put a 1 everywhere there's an x, you will get out a true statement on both sides. Throw in a 2. If you put a 2 in, you'll get out a true statement. You can try any number you want except for 6 and 0, and all of those answers will work. Now, one more thing, and then I'm going to move on. Remember, everything canceled out on both sides, right? Well, what if, now don't zone out here, okay? Listen, because I want to take your education a little further, all right? What if what if all of your x's would have canceled out, so you had 0x and you had a number over here like 5? Like over here, everything canceled out on both sides. You had 0 equals 0. But here, what if all of my x's canceled out and I had a number over here? Well, you'd have to divide by what? 0. And can you divide by 0? No. So the answer here would be no solution. It can't be done. What if you had your x's did not cancel out, but all of your numbers canceled out over here? Well, that's no big deal. You can divide by 2, and x would equal 0. So make sure you understand the difference between these two scenarios. Here, everything canceled out on both sides. Here, all of your x's canceled out, but your numbers didn't. Here, all of your numbers canceled out, but your x's didn't. And so make sure you're familiar with that, okay? All right, moving on to number 31. All right, number 31 is a square root equation, and here are the steps that I've given you. Number 1, you eliminate your square root. So the first thing you do is you get it all by itself, and then you want to eliminate the square root. Well, this square root is all by itself, and it is a square root, so I'm going to raise the left side of the second power, and I can do that as long as I raise the right side of the second power. So whenever you square a square root, you get the radicand. That means the inside. So there's the radicand, and 2 times 2 is 4. And now simply bring the 5 over and make it a positive 5. And you will get 9. And now divide both sides by 2. And 9 divided by 2 is 4.5. Or if you want to put 4.5, that's fine. Okay. Now don't forget, on these equations you do need to check for extraneous solutions, and if you were to put this in for x, multiply it by 2, subtract 5, and take the square root of it, because you do check it, by the way, you check it in the original equation like this. If you were to put 4.5 right here, 2 times 4.5 minus 5, take the square root, you will get equals 2, and so this answer does work. All right, number 35. Again, the same problem. Step 1 is to eliminate your radicals, but before you eliminate them, you must isolate them. And so this square root's already isolated. So because it is a square root, I'm going to raise this left side to the second power, but I must raise this side to the second power. And when you square a square root, you get the radicand, so 1 minus 2x, and then 3 times 3 is 9. Bring this 1 over and make it a negative 1, and you're left with negative 2x equals 8. And now divide both sides by negative 2, and x equals negative 4. Okay, now don't forget, whenever you're dealing with these root equations, you do want to check for extraneous solutions, and negative 4 does work. If you put a negative 4 here, you would get a positive 8, plus 1 is 9, square root of 9 is 3, you will get 3 equals 3. Alright, moving on to number 39. Okay, we're going to eliminate our radical. Well, first of all, you must isolate it completely. You must isolate the radical completely. Okay, on this equation here, we already have the fourth root already isolated. It's all by itself. So we're simply going to raise the fourth root to the fourth power. If you raise one side of the fourth power, you must raise the other side of the fourth power. Whenever you take a fourth root to the fourth power, you get just the radicand. So we're left with x squared minus 1 equals, and 1 times 1 times 1 times 1 is 1. Now I'm going to bring the negative 1 over and make it a positive 1, so I'm left with x squared equals 2. And then I'm going to take the square root of both sides. The square root of x squared is x, and the square root of 2 is plus, minus, or positive, negative square root of 2. Now, there are my answers. The next thing you have to do is check for extraneous solutions. And again, I don't feel too bad with having these tough answers because you've got calculators, and the calculators will work fine for you, okay? Trust me, if you substitute a positive or a negative square root of 2 in here with parentheses, and then square it, and then minus 1 and take the fourth root, you will get 1. Both of these answers do work. Now, you might want to check that and make sure you know how to do that, but both of these answers will work. Number 43, we have a square root equation and we want to eliminate my square root. Well, the first thing you do is you isolate it. So bring the positive 2 over, and if you do that correctly, you're left with the square root of b plus 3 equals 3, because when you bring the negative 2 over, it becomes a positive 2. Now, the square root's isolated, so I'm going to go ahead and raise the left side to the second power and raise the right side to the second power. When you square a square root, you get the radicand, and when you square 3, you get 9. Now bring the 3 over and make it a negative 3, and b equals 6. Now let's take a look here. If you were to check that answer, you would see that 6 does work. Okay, 6 does work. 6 plus 3 is 9, square root of 9 is 3, 3 minus 2 is 1. So 6 does work. Always check your answers on these, okay? Alright, now we want to get rid of this square root right here, so we must isolate it. So we're going to bring the negative 3 over and make it a positive 3, and we're left with 6 on the right side, and a radical right here of 2x plus 1. Now, is the square root isolated? Yes, it is. So in order to get rid of a square root, I'm going to square it. But if I square one side, I must square the other side. Whenever you square a square root, you're left with the radicand. And whenever you square the 6, you're left with a 36. And now we have a simple equation to solve. Let's bring the 1 over and make it a negative 1. And we're left with 2x, 2x equals 35. Now we divide both sides by 2, and x equals 17 and a half, or 17.5. Okay? Now, this is one of the problems we got to check for extraneous solutions. If you were to substitute this into the equation, you will see, let me go back to the original equation. If you were to substitute 17.5 or 17 and a half right here for x, 2 times 17 and a half plus 1, and do all the simplifying, you will get out 3 equals 3. All right, moving on to number 51. This is a cubed root equation, so we want to get the cubed root all by itself, so we must bring the 8 over and make it a negative 8. If we do that correctly, we're left with the cubed root of 6x plus 9 equals negative 3. Okay, very good. The radical is now totally isolated, so because I'm dealing with the cubed root, I'm going to raise it to the third power. If I raise one side to the third power, I must raise the other side to the third power. Whenever you cube a cubed root, you get the radicand. Whenever you cube a negative 3 times negative 3 times negative 3 is a negative 27. And now you're all set. You can solve this rather quickly. Bring the 9 over, and when you bring it over, it becomes a negative 9. So we're left with 6x equals a negative 36. And now divide both sides by x, or by 6, excuse me, and x equals negative 6. So there's your answer. Okay? Now, of course, with root equations, we have to check our answer. So on this problem right here, if everywhere there's an x, you put a negative 6. 6 times negative 6 plus 9. Did all the simplifying, took the cubed root, added 8. You will get 5 equals 5. So this answer does check. Moving on to 55. Okay, it looks like a pretty simple problem, but it's actually not. We want to get rid of the square root, so we must isolate it. So we bring the 5 over and we make it a negative 5. Now these are unlike terms, so you cannot combine them, so be careful there. So when you bring the 5 over and make it negative, on the right side you're left with x negative 5. On the right side, on the left side, you're left with the square root of x minus 3. Now, this is a square root. The square root is now isolated, so I'm ready to eliminate it. I'm going to raise the left side to the second power, and I'm going to raise the right side to the second power. And I think you see now how this problem is going to be a little more difficult than the others. I have a binomial, x minus 5, raised to the second power. Well, let's start over here first of all. Whenever you square a square root, you're left with the radicand, so x minus 3. And if you square x minus 5, of course that means x minus 5 times x minus 5. If you do that correctly and do all your simplification, you're left with x squared minus 10x plus 25. And now as soon as you realize you're left with a quadratic equation, an x squared term, you know right away you want to get one side equal to 0. So I have one x squared term. I'm going to bring that down, cross it off. I have an x term here and an x term here. Let's bring the x over, and when I bring it over, it becomes a negative x. Combine these two, and I'm left with a negative 11x. Cross these off. Now I have a negative 3. I'm going to bring this negative 3 over and make it a positive 3. And if I do that correctly and combine those, I'm going to have a positive 28. Okay? Thankfully, this expression right here, this right side, is factorable. So my factorization of this trinomial would be, notice I have a lead coefficient of 1. So what two numbers multiplied together would give me 28 when added together would give me a negative 11. Well, if you multiply these two numbers together, excuse me, if you multiply, that's incorrect by the way, let's try this again. If you multiply these two numbers together, you will get a positive 28, and if you combine those two numbers, you'll get a negative 11. So the factorization is going to be x negative 7, x negative 4. Now if you take each group and set each group equal to 0, you will get x equals 7 and x equals 4. So there would be our two possible answers. Now, we got to see if these answers work, of course, because we're dealing with root equations. And if you check your answers, 7 is going to be fine. I mean, 7 minus 3 is 4, square root of 4 is 2. 2 plus 5 is 7. You put a 7 over here, you get 7 equals 7. But 4 is not going to work. I'm going to show you why. If you put a 4 right here, 4 minus 3 is 1. The square root of 1 is 1. 1 plus 5 is 6. And you put a 4 over here, you get 6 equals 4. Okay? So 4 does not work. So the only answer is 7. X equals 7. It's so important to check your answers in these problems, okay? All right, number 59, I want to eliminate this radical. Thankfully, it's already all by itself, so I'm going to simply take this square root and I'm going to square it. But if I square one side, I must square the other side. And so when I do that correctly, when you square a square root, you're left with the radicand. And when you square this right side, x plus 1 times x plus 1, you will get x squared plus 2x plus 1. All right? Well, as soon as you see this x squared, you know you want to get one side equal to 0, okay? So bring down your x squared. It's the only x squared term that I see. Here's a 3x. Let's bring that 3x over and make it a negative 3x. And if you combine those two, you'll get a negative 1x or a negative x. Here's a positive 3, bring it over and make it a negative 3. When you combine those two, you'll get a negative 2. Alright, and now we're ready to factor this right side. Notice you have a trinomial with a lead coefficient of 1. So you say to yourself, what two numbers multiplied together give you a negative 2? When combined, give you a negative 1. Well, I'm going to use these two numbers right here. If you multiply these two numbers, you'll get a negative 2. If you combine these two, you'll get a negative 1. So 0 equals x negative 2, x positive 1. And now we take each group and set each group equal to 0. If you set this group equal to 0, you'll get a 2. And if you set this group equal to 0, you get a negative 1. So there are your two possible answers, okay? Now let's see if both of them work, one of them work, or maybe none of them work. Okay, that's definitely a possibility. Well, on this problem here, both of these answers do work. Okay, if you put a 2 in here, you would get 9, square root of 9 is 3, and 2 plus 1 is 3. So if you put a 2 in, you would get out 3 equals 3. If you put a negative 1 in, you would get square root of 0 is 0, and negative 1 plus 1 is 0, so you would get 0 equals 0, and that checks. So both of these answers, in this case, do work. Okay, let's go ahead and continue on now to number 63. Now in number 63, do notice that we have two radicals to get rid of, okay? In this case, there's a positive sign here in front of this radical. I don't care if you move this radical over and make it 5 minus square root of x minus 3, or if you move this positive radical over here and make it 5 minus this radical. It really doesn't matter to me. I usually, just out of habit, move this radical over. But anyways, you want to get one of the radicals by themselves. There's really no right or wrong way to do this. I'm going to make sure this radical here is by itself. That's just my choice. So I'm going to bring the other radical to the other side, and you get 5 minus the square root of x plus 2. Now here's where it gets a little ugly. I have my square root totally isolated, and I've got a square root. So I must square this whole side. So I'm squaring a really awkward binomial here. Well, when you square a square root, you're left with the radicand. And then there is a shortcut you can use on these problems here to save time. Whenever you're squaring a binomial that's identical, like 5 minus the square root of x plus 2 times 5 minus the square root of x plus 2, there's a shortcut. You can square this number here, and that would give you 25. And you can square this whole thing here, and a negative square root times a negative square root would give you a positive x plus 2. The radical's gone. And then you can multiply these two together, which will be a negative 5 square root of x plus 2. And then you double it. So when you double it, you will get negative 10 square root of x plus 2. When you double it, you just double the outside number. And that is a shortcut that will really save you time trying to work with all of this. So there, we have eliminated one radical. Now we've got another radical right here that we have to get all by itself, and then we have to get rid of it, okay? All right, so here we go. So if I'm going to get this radical here all by itself, I'm going to circle it in red. If I'm going to get this radical here all by itself, in fact, I might try something else. Maybe it will work and maybe it won't. If I'm going to get that red part all by itself, then I've got to get rid of this and this and this and this. All of those other things I've got to get rid of. Well, first of all, let's just make this a little easy here. First of all, I have 25. Everybody sees that right here, and a 2. Now don't worry about the 10. The 10 is being multiplied times this radical. We're going to save that for last. I have a 25 and a 2. That gives me a 27. If I bring the 27 over, it becomes a negative 27. Combine these two and I get a negative 30. So that takes care of all my constant terms. Now look at your x. This is a positive x. I'm going to take that positive x and bring it over and make it a negative x. When I do that, these cancel out. They're gone. So I'm left with negative 30 equals negative 10 square root of x plus 2. Now because the negative 10 is being multiplied times the radical, I'm going to divide both sides by negative 10. And now we're finally getting somewhere. A negative divided by a negative is a positive, positive 3, and I'm left with the square root of x plus 2. And now I have a square root, so I'm going to raise my square root to a second power. I must raise the other side of the second power. I'm left with 9 equals x plus 2. Bring the 2 over, make it negative 7 equals x. Now, that answer might work, it might not work. We're going to have to see, okay? So I'm claiming that my answer is 7, and we're going to see if it is. Well, if we put a 7 in here, we get 4, that would be a 2, plus 9, square root of 9 is 3, 2 plus 3, it does work. I end up getting 5 equals 5 when I substitute 7 in, okay? So we're moving on to number 67. Okay, same type of problem here again. I'm going to bring this negative radical over to the other side, and I'm going to make it positive because I have to get one radical by itself. You can either get this radical here by itself, or you can get this radical here by itself. I'm choosing to get this radical right here all by itself. Either way is fine. So I'm left with the square root of x equals 1 plus the square root of 3x minus 3. Okay, now I'm going to raise this square root to the second power, but I must raise this side to the second power. Whenever you square a square root, you're left with the radicand. And then over here, if you use your shortcut, if you square the 1, you get a 1. If you square the square root, you get what's on the inside, 3x minus 3. And then if you multiply these two together, 1 times the square root would be 1 square root of 3x minus 3. And then you double it. You double the outside number. That would be a positive 2 square root of 3x minus 3. Forgot my positive sign here. There we go. So there, we simplified this side right over here. Now, if you'll look, I now have one more radical left that I have to get by itself, and it's in red here, okay? So this radical here in red is what I need to get all by itself, okay? So first of all, I'm going to save this 2 for last. First of all, I have a 1 here and a -3. Combine those and you get a -2. Bring the -2 over and you're left with just -2. Now here's a 3x term. I'm going to cross that off, bring your 3x over, make it a -3x. When you combine that with a 1x, you get a -2x. Very good. And now bring down what you're left over with, 2 square root of 3x minus 3. Now the radical is not by itself yet completely. Now you've got to divide each term by 2. So we divide each term by 2, and we're left with, cross these off, we're left with the square root of 3x minus 3. 2 divided by 2 would be a -1. Here your 2's cancel, leaving you with a -x. Okay? So we've got some work to do still yet, unfortunately, okay? Now we have a square root to get rid of on the right side. And in order to get rid of the square root right here, we're going to have to raise it to a second power. But if we raise the right side of the second power, we're going to have to raise the left side of the second power also, okay? So if we do that correctly, if you take -x minus 1 squared, you will get x squared, positive 1. I'm trying to do this in my head here. And you would get this times this would be a positive 1. Combine those, you'll get a positive 2x. So if you took -x minus 1 times -x minus 1, you should get this here if I didn't make any mistakes. And when you square a square root, you're left with a radicand 3x minus 3. Now as soon as you see that you have a square term, you know right away that you're going to want to get one side equal to 0. So we're going to bring our x squared down, bring the 3x over and make it a -3x. That would be a -1x. Bring your 3 over and make it a positive 3, and that's going to leave you with a 4. Okay, a 4. Now, positive 4. Now let's see what we can do here with this problem. Okay guys, you saw me pause the video there. If I was in class teaching students, no one's perfect, everyone makes mistakes, and usually students will raise their hand and say, Mr. Hart, you made a mistake here or there. It happens to anyone, and what's frustrating is I made a mistake. I started looking at the problem here and I was like, wow, something is not right. And so I did what I'm doing now. When I paused the video, I backed it up and I looked, and you guys probably saw this mistake, but there's nothing you can do. You can't talk to me, but right here, when I said, and I'm really sorry I made a mistake, guys, but it happens to anyone, it happens to all of us, but right here, 1 minus 3 is -2, and when you bring the -2 over, it becomes a positive 2, and I put a -2. Let me go over that again. 1 and -3 is -2. When you bring the -2 over, it's a positive 2, okay? All right, now we bring the 3x over, and when we bring it over, it becomes a -3x. That's a -2x. Okay, so that's going to make a big difference, and I apologize for that mistake. Bring down your 2 square root of 3x minus 3. Now hopefully I'll make no more mistakes. Divide by 2, divide by 2, divide by 2. These cancel, and you're left with the square root of 3x minus 3. 2 divided by 2 is 1, a positive 1. Now the last time I had a -1 here, and then -2 divided by 2 is a -1x, or a -x. Now we have to get rid of this square root, we have to square both sides of the equation, and when you square a square root, you're left with a radicand, 3x minus 3. And when you square this here, you will get x squared, and then a 1, and then a -2x. And that -2x right there is going to make all the difference in the world. You're going to see that this is going to be factorable here in just a second, okay? So I do apologize for that mistake. If I was in class, I'm sure some student would have called it out. Okay, here's your x squared, bring it down. Now I'm going to bring this 3x over, make it a -3x. When I do, I'm left with a -5x. And then I'm going to bring this -3 over here, and when I do, it becomes a positive 3. and so I'm left with a positive 4. Now, I can definitely factor that. What two numbers multiply together give me 4? When add together give me negative 5? Well, a negative 4 times a negative 1 is 4. When you add those, you get a negative 5. So the factorization would be x minus 4, x minus 1, and then when you solve these parentheses, you'll get x equals 4 and x equals 1. So there's my two possible answers. And again, for the third or fourth time, I do apologize for making that mistake. Well, when you check your answers, you're going to see 4 doesn't work. The square root of 4 is 2. Here you would get 12, 3. Square root of 9 is 3. You get 2 minus 3 equals 1. So you get negative 1 equals 1. And that does not work for the number 4. 1 does work. If you put 1 in, you will end up getting 1 minus 0, which is 1. You get 1 equals 1 when you substitute 1 in. So 1 is your answer. Okay, number 71, moving on. Again, the same type of problem where I'm going to isolate the square root of y plus 4. And I'm going to bring this negative radical over and make it positive. So 1 plus the square root of 1 y minus 1. Now, to get rid of the square root on the left, I'm going to square it. But if I square the left side, I must square the right side. When you square a square root, you're left with the radicand. Over here on the left side, I'm going to use my shortcut. When you square 1, you get 1. When you square the radical here, you get what's in the inside, y minus 1, a positive. And then, when you multiply these two together, you get 1 square root of y minus 1. And when you double that, you will get 2 square root of y minus 1. So there, we're doing pretty well. Okay? Now, I want to get this square root, this radical right here, in red, all by itself. Okay? And so I'm going to have to get rid of some 1s and this y. So first of all, the 1s are pretty easy. Look at this. Remember, I want to get what's in red all by itself. So I've got to get rid of a 1, a 2, a y, and a 1. First of all, a positive 1 and a negative 1 just cancel out. Secondly, do you see this y right here? Bring this y over and it becomes a negative y, and these cancel out. So you're left with a 4 right here equals a positive 2 times that radical. Okay, so we're doing pretty well. Now all that we have to do is simply divide this side by 2 to get the radical by itself. Divide this side by 2, these cancel, and 2 equals the square root of y minus 1. Well, we can square this square root, but if you square one side, you got to square the other side, and you get 4 equals y minus 1. Bring the negative 1 over, make it positive, and you get 5 equals y for number 71. So you're saying, I think this is my answer. Now when you're dealing with root equations, you need to check your final answer. If you put a 5 in here, you get 9. Square root of 9 is 3. Put a 5 here, 4. You get 3 minus 2 equals 1, and that's correct. 1 equals 1. Okay, moving on to 75. Now, don't let this freak you out. We've talked about this before. X to the 1/3 just simply means the cube root of x. So go ahead and rewrite that as the cube root of x. Okay? Now, having done that, we simply notice our radical is already isolated. So to get rid of a cubed root, we cube it. But if we cube one side, we must cube the other side. When you cube a cubed root, you're left with just what's on the inside, the radicand. And if you cube a negative 2 times negative 2 times negative 2 is a negative 8. So we are submitting this as our final answer. And so we're going to put negative 8 in for x. So parentheses, negative 8. Remember, you always check these in your original equation. And if you will type this into your calculator right here, this negative 8, put it in parentheses to the 1/3 power, and then check everything, you will see that you get out a true statement, okay? You do get out negative 2 equals a negative 2. They check. And so the answer is negative 8. Now let's move on to number 79. Okay, well so far, let's review real quick here guys. So far, let me use a different button here on my computer. So far we did rational equations, all these fractions. Then we did root equations, a bunch of those. And now we're getting into some absolute value equations, okay? Number 79. Well, what I've taught you to do on these is step 1, Isolate the absolute value. We've already done that. And then step 2, you write two equations. First of all, you write the equation just like it is without the absolute value bars. So x equals 7. Then you take this equation here and you rewrite it, only you change the sign of this number right here. So x equals -7, and then you solve each equation. Well, you can't really solve these, they're already done, so there's your two answers. X equals positive -7. Number 81. Okay, let's solve this absolute value equation. Now the first thing you do is you isolate the absolute values. Well, they're already isolated. So the next thing you do is you write the equation just like it is without the absolute value bars, excuse me. So x minus 1 equals 4. Then you rewrite the equation again. So we take this equation here and we write it just like it is, except we change this number right here to a -4. Nothing else changes. Now we solve this equation. X equals 5, bring the 1 over and make it positive, and then we solve this equation, bring the 1 over and make it a positive 1, and we're left with -3. You do not need to check your answers on these absolute value equations, okay? They are what they are. All right, number 87. Now, first of all, you isolate the absolute value, get it all by itself, it's already done. Then you write the equation just like it is without the absolute value bars. We've done that. Then you write it again, only you change the sign of this number right here. Well, really, I mean, you're welcome to put a -0, but there's no such thing. And then you solve each equation, but you really can't solve it. The answer is just 0. X equals, and that makes sense. I mean, what number could you put in for x here that when you take the absolute value of it, you get out of 0. The only answer is 0. Okay, number 91. Well, it's an absolute value equation, so the first thing that we do is we isolate the absolute value, and it's already isolated. So the next thing we do is we then write two equations. First of all, you write the equation just like it is. Don't change anything except you take away the absolute value bars. Then you write the equation again, only this time you change the number that's all by itself on the right side, so we put a -17. Nothing else changed. And now we solve each equation. So I'm going to bring down my 1/2 x equals, bring the 5 over, make it positive 22. Now divide both sides by 1/2, and you will get 44 for one answer. Okay? Then we come over here and we bring the 5 over and make it a -5, so we're left with 1/2 x equals -12, I believe it would be, and then divide both sides by 1/2, and you will get a -24. So one answer is 44 and one answer is -24. Okay, moving on to number 95. Once again, it's an absolute value equation, so you must isolate the absolute value. In this problem, the absolute value is not isolated, so we bring the 2 over and we make it a positive 2. The 2 is now gone. So we're left with the absolute value of x plus 3 equals 10. 8 plus 2 is 10. Now, is the absolute value isolated? Yes, it is. So you're ready to write your two equations. You write the first equation just like it is. Just take away the absolute value bars. Then you come over here and you write this equation again the exact same way, only you change the 10 to a -10. And now we're ready to solve. Bring the 3 over and make it a -3. X equals 7. Here we bring the 3 over and make it a -3, and x equals a -13. So there's your two answers, 7 and -13. Moving on to number 99. Okay, we must first isolate this absolute value. So you must bring the 1 over and make it a -1. So the 1 is gone, and we make it a -1 over here. So we're left with the absolute value of 4x minus 3 equals 6, 7 minus 1. And now because the absolute value is isolated, we now can write the equation two different ways. First of all, we write the equation like it is without the absolute value bars. And then we take this equation here and we write it again. The only thing that we change is the 6 to a -6. And now we're ready to solve. Bring the 3 over and make it a positive 3. 4x equals 9. Now divide both sides by 4, and you will get 9/4, or you can put 2 1/4, or 2.25. All of those are fine. Over here we bring the negative 3 over and make it a positive 3. So when you do that, you're left with a negative 3. And then divide by 4, and your answer is a negative 3/4, or a negative 0.75, whatever you would like to put. Okay, so there are your two answers, negative 3/4 and positive 9/4. Now these last two problems, 103 and 107, I know that we didn't cover those in your notes, but I know in the past we've learned how to solve multivariable equations, and I want you to be very familiar with these. Okay, so let's do 2 of these, and we're finally done with the whole homework assignment. Notice on this expression here, this is not really part of the equation. You guys should understand that. It's just telling us what to solve for. We're solving for t subscript 1. So that's what we want to get all by itself, is this right here. Now my suggestion to you is you look at this and you say, okay, a common denominator for this whole fraction would be t subscript 1, t subscript 2, put it over 1, and I would multiply the entire equation by this fraction to get rid of your fractions, like this. Take this fraction here times this fraction here. Notice your t subscript 1 would cancel with t subscript 1, so you're left with t subscript 2 times this monomial right here, p1 v1. And if you multiply that correctly, you will get t2 p1 v1. And now take this fraction times this fraction over here. Notice your t subscript 2 will cancel with your t subscript 2, and you're left with t1 times this. So you really get t1 p2 v2. Now, don't forget what you're solving for. You're solving for t1. So you want to get t1 by itself. Now, please notice all of these letters here are being multiplied together. It's one term. You can't just bring the p2 over and make it negative, or bring the v2 over and make it negative. This is all one term. So you must divide to get rid of the p2 v2. So we divide both sides by p subscript 2 v subscript 2. These cancel, and look what you've done. You finally got t subscript 1 all by itself. And over here on the right side, there's nothing you can cancel. Please don't try to cancel the p's or the v's, because one is a p1 and one is a p2 and one is a v1 and one's a v2. So there we go. We did it. We got t subscript 1 all by itself. There we go. One more problem, we're finally done. Okay, let's solve for p. All right, let's solve for p. Now, first of all, for me, I'm going to find a common denominator, and a common denominator for f, m, and p is going to be f, m, p over 1. And I'm going to multiply this entire equation by this to get rid of my fractions. So this fraction times this fraction, notice your f would cancel with your left, leaving you with mp times 1. So mp times 1 would be mp. Then take this fraction times this fraction here. Notice that your m would cancel with your m, leaving you with fp times 1. fp times 1. And fp, bring down your equal sign, fp times 1 would be fp. And then we take this fraction here times this fraction here. Notice your p would cancel with your p, leaving you with fm times 1. Bring down your positive sign, that's fm. Now please don't lose sight of what you're solving for. You're solving for p. Now there's two terms with a p. This term here has a p and this term here has a p. So my suggestion to you is get both of them on the same side. So I'm going to bring fp over, it's one whole term, bring them over together, and it becomes a negative fp, leaving you with fm over here. Now again, what are we solving for? We're solving for p, correct? So we're going to factor the p out, and we're left with m minus f equals fm. So I pulled my p out. Now I'm going to divide this side by m minus f, and I'm going to divide this side over here by m minus f. This will cancel with this, leaving me with p. So I'm left with p equals f m over m minus f. It was very important that you pulled your p out, okay? You had to factor this p out, so you were left with m minus f. Now, having said that, please don't do any canceling over here in your answer. You have two terms in the denominator, one term up here. Don't cross off your m's or cross off your f's. You cannot do that, okay? And there's your final answer. So we did a really marathon of a homework assignment. I hope you guys have been helped by this homework help video. Call or email if you have any questions.